We're looking at mixed exercise 6 from the first year core textbook, so we're on circles. We're looking at question 25. So I'm told that these 4 points rely on a circle, but before we get onto the circle, they just asked me to find the perpendicular bisectors of 2 pairs of those points. Okay, so AB, these are not drawn to scale, these are not in the correct positions necessarily, might have got lucky. So what do I need? So the perpendicular bisector is going to be perpendicular, so at a right angle to that line and going through the middle of it. So I need the midpoint. So the midpoint is just the mean average of the coordinates, so -7 + 1 all over 2 for the x coordinate and 7 + 9 all over 2 for the y coordinate. So that's going to be -6 over 2 and 16 over 2. Okay, so that's the midpoint. So the perpendicular bisector is going through that point. I need the gradient. So the gradient of AB is change in y, so 9 - 7 over change in x, so 1 - -7. So that is going to be 2 over 8, sorry, 2 over 8, so a quarter. So that's the gradient of AB. So the perpendicular gradient that I want to use is the negative reciprocal of that, so -4. So I'm going to use y minus y1 is m times x minus x1. So y minus, so that's my y coordinate. That's my x coordinate, and that's my gradient. Okay, so y minus 8 is my gradient times x minus -3. They didn't ask for it in any particular form, so I'm just going to multiply out those brackets, and then I'll do it in the form y equals mx plus c. But any correct equivalent would be fine. So y plus 4x plus 4 equals 0 would be absolutely fine. Okay, so that's the perpendicular bisector of AB. Did they ask that one? Okay, so that's part 1. Okay, so for part 2, so exactly the same thing. So but this time I'm doing it for C and D. So let's make a note of those coordinates. So C is 3, 1, and D is -7, 1. Okay, so we'll just do the working for this one. So I'll move it up so you can remember the steps we did before. So the midpoint is the mean average, so 3 + -7 over 2 and 1 + 1 over 2. So the midpoint is -4 over 2 and 2 over 2. So you can see that. Okay, so that's going to be the midpoint. The gradient of CD, so change in y, so 1 - oh, okay, so right, he's going to be, so actually I think I will want to sketch this, because I'm going to have 1 - 1, the change in y, over 3 - -7. So that's going to give me 0 over 10, which means the 0 is kind of irrelevant because CD has got a gradient of 0. And that obviously makes sense because when you look at the coordinates, they're both going through y as 1. So basically CD is that line there. Yeah, it's a perfectly a horizontal line. Okay, and we want to plot, and then so C, which is 3, 1, is about there, and D, which is -7, 1, is about there. Okay, so perpendicular bisector, well, we have figured out that it goes through -2, 1. And what's the perpendicular line going to look like? Well, the perpendicular to a horizontal line is going to be a perfectly vertical line. And that type of line has the equation x equals, and it's going through, you know, it goes through x is -2. So it has the equation x is -2. And so that's the perpendicular bisector of CD. That's my answer to part 2. So yeah, sketch was quite helpful those to clarify what was going on. Okay, and then find the equation of the circle. Okay, so I suspect we're going to find that that working is relevant somehow. So what have we got? Well, we've got a circle. Again, I'm not going to plot these accurately. I'm just going to sketch out what's going on, and hopefully it'll jog my mind to maybe a circle theorem that's relevant. So we've got AB, and we have just found the perpendicular bisector of AB. So if you remember your circle theorems, the perpendicular bisector of a chord will go through the centre of the circle. So then, if I've also got the perpendicular bisector of CD, that is also going to be going through the centre of the circle. So mine is not drawn to scale, but the two equations I had, so the perpendicular bisector of AB, we had there. So I've got this line where the equation, so I've got the perpendicular bisector of AB, and I know that the equation of that is y minus 4x minus 4. I've got the perpendicular bisector of CD, which I know is the equation x is minus 2. So remember, this is not drawn to scale. Clearly that is not the line x equals minus 2, but I was just using it to think about my circle theorems. So the centre of the circle is going to be where those two lines cross. So that's easy enough to find. Those two lines are going to cross. So where do these two lines intersect? Well, if I just substitute the x is minus 2 into the second one, so if x is minus 2, y is, so that's going to be positive 8 minus 4, so y is 4. So the centre of the circle is minus 2, 4. Okay, and then the radius, well, I've got 4 different options I could use. The radius is just going to be the distance from the centre to any of those 4 points I've got on the circumference. So we might as well use A because it comes first alphabetically. So A was minus 7, 7. Okay, so R is going to be the distance between minus 7, 7 and the centre of the circle. So minus 7 minus minus 2 all squared, and 7 minus 4 all squared. So that is going to be the square root of 25 plus 9. So R is root 34. So if I put that radius and the centre of the circle into the equation, so it's going to be x minus minus 2 all squared plus y minus 4 all squared is root 34 squared. It's just 34, hopefully. Let's find out. X plus 2, y minus 4, we're good. Yeah, brilliant, we're good.